Hello, my name is Marie van Wyk and I am teaching the syllabus 9709, paper 2, the topic logarithms, logarithmic and exponential functions, the very first item. Understand the relationship between logs and indices and use the laws of logs. Right, now, just first of all, to understand what a logarithm actually is, look at this simple statement: 36 equals 6 squared. You probably know that the 6 is called a base, and the 2 is given 4 different names, one of which is index. It's also known as an exponent, sometimes as a power, but the name that is most relevant to us is logarithm. So what I'm trying to show you here is that a log is just simply another name for a power or an index or an exponent. Now, this statement can be read in any language, but I'm going to put it into a different form in words. I'm going to write it like this: the power of 6, which gives 36, is 2. And then I'm going to break this statement down into little bits and rewrite it in a mathematical notation. So for the power, we're going to put log of 6, we write that down here as a base, which gives 36 there, is 2, or equals 2. So when we read this, we either say log to the base 6 of 36 is 2, or to understand it, what it means, we say the power of 6, which gives 36, is 2. Now, if you understand that, you shouldn't have any problems with logarithmic work. So let's look at a couple more statements. Please note that this original statement there is in what we call power form. Whereas this one here is in the logarithmic form, or log form. They're different forms of the same statement. They both tell us the same fact. So let's look at a couple more statements. If I said to you 16 equals 2 to the power 4 and asked you to write that in log form, you need to say to yourself, well, I'm talking about the power of a particular number giving another number. So the power, now it's the power of which number? Which number is our base? It is the 2. And the power of 2, which gives us the 16, is 4. So those two statements are equivalent. If I asked you what is log to the base 3 of 81, I'm basically saying what power of 3 will give 81. Now if you don't know the answer, what you could say is let the power of 3, which gives 81, equal x. And then we translate that or change it into the power form. So, which is our base here? It is 3. 3 to the power of x, 3 to the power of x equals 81. And we need to find out what power of 3 will give 81. If you don't know what it is, you can always break the 81 down into nines. You could say it's 9 squared, and then the 9 is 3 squared squared, and as you should know, that will give you 3 to the power of 4. In other words, x equals 4, or the power of 3, which gives 81, is 4. You need to be comfortable in going from the power form to the log form, or the other way around, from the log form to the power form. So let's take a few more examples. If I said to you, change from log form to power form for these expressions, let's say this is the power form column, and this is the log form of the same statement, or same fact. 10 to the power of 3 equals 1,000. Second one, 8 cubed is 512. The third one, log to the base 10 of 0,001 equals -3, and a fourth one, log to the base 3 of 1 over 27 is also -3. Right, let's see if we can translate those. Here we're saying that 10 cubed is 1,000. Now to put it into log form, you've got to say that the log, or the power, of a particular base gives us another number. Now the base in this case is the 10, and the power of 10, which gives us 1,000, is 3. Now think for a moment, how would you rewrite the second statement? 8 cubed equals 512. The power, what is our base? The power of 8, which gives us 512, is 3. And then conversely, or if we go the other way, if we translate this statement, it says the power of 10, which gives us 0,001, is -3. Start with your base. Base is 10. The power of 10, which gives us 0.001, is -3. In other words, 10 to the power of -3. Sorry, I'm having problems with my pens. 10 to the power of -3 equals 0,001. So just think for a moment and try to write down the power form of this logarithmic expression in number 4. What is your base? 3. What is the exponent, or log? It's -3, and that will give you 1 over 27. Okay, so that's the first thing you need to understand about logs and indices or exponents. At this stage, I would give the class a chance to practice a few questions, examples. Right, the next thing you need to understand is that in maths we write the log to the base 10 of any particular number. I'll call it A. We leave out that 10. So if you have a log run like this with no base written, it automatically means base 10. A couple of other pointers. if I asked you what is the log to any base of 1, I'm saying to you what power of b will give you 1. Now, if you know your exponents, you should know that anything to the power 0 is 1. So the log of 1 will always be 0. Doesn't matter what your base is. Your base must always be positive, and we cannot find the log of anything which is negative. So if we talk about the log of a to any base, we mean that only exists, that only exists if b is, my apologies, if a is greater than 0. And then just one other thing, look at this statement. If I said to you that the log of to the base b of a equals x, then clearly a would be b to the x. Now, we could say from here that b is the xth root of a. In other words, b is a to the power 1 over x. And if we put that into log form, we could say that the power of a, which gives b, is 1 over x, which was log to the base a of b. Log to the base b of a, I mean. So if you notice that there, it's 1 over log to the base b of a. That's a very useful fact. In other words, if we take a numerical example, if I tell you that the power of 2, which gives you 8, is 3, and then asked you what power of 8 gives you 2, by this fact here, you should see that it will be 1 over 3. Now, just to clarify that, just to prove that it is in fact true, 2 cubed is 8. And so if you take the cube root of both sides, 2 would be the cube root of 8, or 8 to the power 1/3, which is what this says here. That wasn't very good, writing where you can't see. So let me just move this information to the top, or tilt my camera slightly. There we go. Okay, I hope that that is clear. There are a number of laws of logs that you need to be aware of, so let me just go through them with you. Before we actually prove the laws, we're going to start with some introductory statements. Let's suppose that we deal with the number m, and that it is a particular base b to the power x, and then another number n is the same base to the power y. And we're going to just rewrite these two statements in log form. So we're going to say the power of b, which gives us m, is x, and the power of b, which gives us n, is y. Now the first law is to do with the product of m and n. If we were to multiply m by n, we would say, okay, m is b to the power x, and n is b to the power y. So when you multiply by your rules of exponents, you add your exponents. You get x plus y. Now let's put this statement into log form. So we'd say the power of our base, which gives mn, is x plus y. And then to complete this, we go back to our original definitions up here, and x is the log of m, log to the base b of m, and y is log to the base b of n. And there you have the first law of logs, that when you multiply two numbers, you would add their logs. Now the second law is very similar to this. It's to do with division, and I'd like you just to spend a few minutes on your own trying to prove the second law, where instead of m times n, you are working with m divided by n. And I think you will find it pretty straightforward, just following the steps but using the rules for division of exponents. And see, if you should come up with a second law where instead of putting x plus y for multiplication, you're going to put x minus y for division. And you do this as an exercise for yourself. You should land up with the log of m divided by n is log to the base b of m, subtract log to the base b of n. That's your second law. And then the third law the third law is to do with raising m to a power. Remember, m was b to the power x. So if I raise m to a power p, that's the same as raising b to the power x to the power p. Now if you think back to your laws of exponents, when you have b to the power x raised to the power p, what rule do you apply with the x and the p? And if you remember, it is multiplication. So m to the power p would be b to the power x times p. And now if we put that into log notation, you'd say the log to the base b of m to the power p is that exponent x times p, but I'm going to put the p first for convenience, and you land up with this third law of logs, that the log of m to the power p is p log m. X is the log of m, remember. Okay. At this stage I would do a number of examples illustrating the laws. But we'll stop there. Thank you.